So in this short flip class video, we're going to introduce the notion of vectors. You may have already seen vectors in a class such as a physics class. We're going to introduce them here from scratch. So let's notice here that up to this point, we've been dealing with numbers and functions where the functions inputted numbers and outputted numbers. But we know in the real world, usually a number isn't necessarily enough to give us all of the information we need. So for instance, if I wanted to give you directions to a coffee shop, if I tell you to walk a mile and you'll be at the coffee shop, that doesn't do you a lot of good. You don't know which direction you have to walk to get to the coffee shop. I need to tell you both a distance to walk and a direction to walk in. So this is what a vector is. It's an object that has a magnitude and a direction associated to it. So we'll often denote vectors either in bold or with an arrow over the top of them. And then the magnitude of a vector, we'll use this double kind of absolute value sign. It's the norm of the vector, which is the magnitude of the vector. So that's how we'll denote the length of the vector. So I already mentioned one example. Displacement is an example of a vector. So I walk 1 mile north, for instance. That gives me a magnitude of 1 mile in a direction of north. And similarly for velocity, I can say I drove east at 70 miles per hour. So in this case, the magnitude is the 70 miles per hour and the direction is east. So generally when we draw vectors, we're going to draw them as arrows. And so this is the vector v here. And it's not tied to a particular location. It has a magnitude and it has a direction, but it's not fixed to a particular location. So for instance, all of these vectors here are still the vector v because they have the same magnitude in the same direction. It doesn't matter where I place the vector. It's the magnitude and the direction that determines the vector. Of course, we can also scale our vectors. So you can imagine if you're traveling velocity, so say 70 miles per hour going east, you could then double the speed but continue going east. So now you're going 140 miles per hour and going east. That's also a vector. So for instance, here's an example. Here's our vector v, and notice 2v goes in the exact same direction as v. We've just doubled the length of v. So we denote that by 2 times v. That 2 is what's referred to as a scalar, and we're scaling the vector by that 2. We can scale by negative numbers as well. So if I scale my vector by a -1 here, so I have negative v, it's the same magnitude. It just goes in the exact opposite direction of v. So for instance, if I was going 70 miles per hour east, and that was my vector, if I took the negative of that, I'd be going 70 miles per hour west. We're also going to want to add our vectors. So scalar multiplication we just saw. Now we want to do vector addition. So we can imagine we have two different displacement vectors. So you walk, 1 mile east, and then you walk 1 mile north. And you can think of those as two different vectors, the 1 mile east and then the 1 mile north. And we can add those two vectors to get our total displacement from where we are from where we started. So for instance, if we have two vectors here, v and w, let's see the process for adding these vectors geometrically. So my first step is going to be, I'm going to take the vector w, and I'm going to place it at the tip of the vector v, as seen here. Now to get the addition, I'm just going to connect the beginning of the vector v with the end of the vector w, and that gives me v plus w. So that's how I draw the vector v plus w. And you should convince yourself, maybe take a second to pause the video and draw a picture, that it doesn't matter if we go v plus w or w plus v, I get the same vector at the end. So v plus w is w plus v. So go ahead and check that on your own. In the last operation we want for this first introductory viewing of vectors is subtraction. So this is a little bit more complicated than addition, but we're really going to use addition to see how to addition and scalar multiplication to see how to do subtracting vectors. So when I write v minus w, I could also think of that as v plus minus w. And we know how to add two vectors. And I know how to scalar multiply w by -1, it just changes the direction. So one method to view this is notice that if I take v minus w and I add w to it, the w's will cancel out and I'll just get v. So that means the vector v minus w should be the vector that when I add it to w, I get v. So remember now, to add the vectors here, we would say this vector w, if I want to add it to v minus w, I put v minus w at the tip of that, and we know the answer should be v. So if I was to draw v and w, I place v minus w's going from the tip of w to the tip of v. So that's one way to think of how you can do vector subtraction. And there's one other way to think of this as well, is we could view v minus w, how we motivated at the beginning, is it's v plus minus w. So I go to v and I add minus w to it, and I get this vector here, v minus w, going from v to the tip of negative w. So that's another way to view v minus w. And you can see it looks different because before our v minus w is up here, but remember v minus w doesn't depend upon the location of the vector, it's only the magnitude and direction. So if you look at this vector, what it looks like, where the magnitude and direction, and then look back here, it's the same vector as this. They're just drawn at different places in the plane, but otherwise they're the same vector. So we get the same thing here, regardless of how you want to think of the vector subtraction. So that's our first introduction to vectors. We'll do more with them, and they're going to be very important for the rest of the course. The whole point here going forward is we're going to learn how to do calculus with vectors, because a lot of the functions we're interested in actually involve vectors. And so we need to understand how to do calculus with those types of functions.